Okay, we want to talk about the word relations. Okay, relation is a relationship between two quantities. Okay, so let me give you an example, a very simple example. Let's say one apple costs $2. Okay. Then two apples. I don't want to draw a lot of apples. I'm just going to say two apples will cost $4. Three apples will cost $6. So this is a relationship. It's not always going to increase in direct proportion like this. So, if one is 2, 2 is 4, I'm just doubling, right? Every time I increase by 1, so I'm not doubling, I'm just increasing it by 2. Increasing it by 2, right? But in real life, you could have, let's say, 6 apples, and it could be in a bag, and instead of costing $12, it could cost $8, because, there's a deal for more you purchase. Now, the thing that we want to really understand is a linear relationship in this section. Linear relation. Okay, what is a linear relation and what is not a linear relation? So what you saw here, as I increased the apple quantity by 1 was $2. If you increase it again, it goes up by the same proportion. $4, 3, right, $6. So every time this increases by 1, this increases by 2. Such a relationship is called a linear relationship. And if I were to actually graph this, right, where this represents number of apples, and the y-axis represents the cost, and we call this here the independent variable. Okay, independent variable, and this one here dependent. Okay, so when we want to talk about quantity, we first want to talk about quantity and then talk about the price depending on how many apples you have. Okay, so if you have 1, it was 2. If you had 2, it went up to 4. If you were to graph it, right, if 3, it'll be 6. You get a straight line, okay, if you were to graph it. Okay, so that also, it matches with the name, linear relation. Let's try to come up with an equation for this cost. Okay, so cost, for every apple, right, it costs 2. So $2 per apple, where n represents number of apples. So if it's 1, right, if it's 1, it should be 2. If it's 2, it should be 4. So cost is equal to 2n actually is the relationship. Okay, and if you're familiar with the equation of a line, this looks like y equals 2x. Okay, we'll talk about that a little bit more in depth, but for now, that's the equation. Okay, and all linear relationship look like this one. Okay, there's two variables, there's no exponents of any kind, just a constant and two variables. Okay. Let's not talk about a nonlinear relationship. So what's the nonlinear? Right, let's talk examples. So suppose you have a square. Okay, a square of edge 1. What is the area? Okay, so if the side length is 1 centimeters, let's say, then the area is equal to 1 centimeter squared. So it's 1 centimeter squared. If it's 2, right, if it's 2 centimeters, then the area, so let's say here, this is the side length and this is the area, it'll become 2 squared, so it becomes 4 centimeters squared. And if it's 3, the edge length is 3, it's 3 squared, so it becomes 9 centimeters squared. Now this is increasing by 1. How about this? It's increasing by 3, and then it's increasing by 5. Not the same. Okay, if you were to graph this, right, when it's 1, it's 1. When it's 2, it's 4. Okay, when it's 3, it's 9. 4, 5, 6, 7, 8, 9. Okay, so it's actually going to look like this. is the shape of a parabola. And the important thing is it's not a line. Okay, so these are called non-linear relations.